Hi, are you tired of writing endless if statements just to validate data in Python? Meet Pydantic, our new best friend for data validation and settings management, powered by Python type hints. In this video, I'll walk you through what Pydantic is, why it's awesome, and how can you use it to write cleaner, more reliable codes. And by the end, you will understand how to validate, parse, and build robust models really. Let's dive right in. What is Pydantic? Pydantic is a Python library that lets you define data structures using classes, and it automatically validates and parses data to match those structures. It's heavily used in frameworks like FastAPI, but you can use it in any Python project that deals with user input, uh, JSON, APIs, or config files. It uses Python type annotations to define the structure and validates the data at runtime with a basic simple data class. Here we have defined students with types: name as string, roll number as integer, percent score as float. Now here is the thing: if I pass 85 as a string instead of float, it is Python is accepting it happily and giving no errors, no warnings. Data class in Python don't enforce type validation at runtime; they are just for reference. Now let's convert that same class into a Pydantic class. We define student to from base model and keep the same fields. Everything looks familiar, but with one major difference. Pydantic validates and converts type. It passed 85 as a string, but Pydantic automatically turned it into a float. Type safety with flexibility. That's the magic of Pydantic. Now, what if I change this roll number to non-convertible value of int? For example, we had int here, which was even if you pass it as a string, it was able to convert it. But what if we pass it a string only? Then it will throw an error in this case. We can also write it in a try catch block so as to see get that validation error in the except block. You can also add optional fields using optional from the typing module. Commission and inactive are now optional with sensible default values. This is perfect for building APIs or data models where not everything is required. Let's create a user model with an additional commission and inactive flag where if we don't pass commission, it will take it as done. And if we don't pass inactive, it will by default take it as true. That's more clean and concise. So I'm just passing ID and name. ID is one, name is 4404. So it is just so if we print the user, it is printing those two along with the default values of permission and is active. Similar, if we just pass permission along with the extra of the above users, we will see we passed 1000, but here it came as 1000.0, which is the float value, which automatically typecasted. And the other which we didn't pass was is active, which it by default took as true. We can also validate a list of strings. Here is another cool feature, validating list. To the above example, I've just added commission taken from, which is a list of strings, and we can see that I've added the commission taken from ABC, and it has successfully validated the input list input. Now, but what if here I passed all the strings? What if I pass a sneaking number like 123? Boom! It gave error. Pydantic throws a validation error again. Every single list item is checked against the expected type. So powerful. If we see here, we were supposed to have list of strings, but I passed integer, and hence it gave the error. Now we can build complex structured models like JSON objects. Python Pydantic supports nested models. You define address model, and we can use it inside the customer where if we can see customer has customer ID of int type, name of string, and address is of Pydantic class address. And now when we add a address, when we call this object here, we will see all the attributes of outer class have key equal to value. But for the inner class like address, we have to pass it in JSON format, key colon value. And we can see that it has successfully validated the input and we are able to see the output successfully. We can also add the constraints here. Name must be of minimum length x and maximum length y. Similarly, some integer values or float values can have greater than less than constraint. So, and similarly, we can have for the names, we can also have regex patterns. Default we have already seen above. So, for example, we have a class order which has inherited Pydantic class. Name is a parameter of it which is of string type. We have defined the minimum length of the name should be 3 and the maximum length should be 50. Similarly, for the quantity, the minimum, the smallest value it can have should be greater than 0 and the maximum it can have up to 5. Similarly, for price, it has just the lower bound of 0. It should be always greater than 0, else it will throw a validation error. And here we can see it successfully validated the data. We can also add the descriptions in the field command. So if we see here, I have not passed anything else here. I have just added dot 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 comma. So which means I am not adding any constants, any default values, any constraints. I have just added the description to it, name of the user. Similarly, for quantity, I've added the greater than constraint, less than constraint, default value if you don't pass anything, and then the description. And similarly for the price. And we can see it has successfully validated the data. Now, if we need to generate the JSON schema of our class, we just need to call model JSON schema. So, how this is helpful is this is mainly helpful when documenting APIs or building front-end integrations. And that's a complete walkthrough of Pydantic. It's one of the most underrated yet essential Python tools. If you, if this video helped you, hit that like button and subscribe for more Python content. And let me know in comments, should I do FastAPI plus Pydantic tutorial next? Thanks for watching. Happy